allow the users, the cloud platforms, to input the data. But some people enter wrong data. Some of the locations are wrong. So if you pin those locations and try to navigate, you find it's not correct. So roads also, if you take the example of road maps, if somebody modified the road and put wrong connections, say for example, we have a highway and we have a underpass road. So from the road, you cannot get into the highway because it's an underpass. You pass the road under the highway. But somebody can edit this and put as an intersection, which is not correct. So then people who look at the roads and try to locate a route path will find that, okay, you can enter to the highway from this road and come and find that it is wrong. So it is not correct. You need to protect this data. When you release it to the public, people should not be able to modify it without really evaluating the accuracy of the data. So the organizations which contribute data must secure their data so that you can maintain the quality of the data. So that security part works in a number of ways. People cannot just add anything into this data, but there's always provision for improvement of data. You can improve the data, you can add value to the data, but that should be modified, that should be monitored, that should be controlled, and that should be more or less given proper scrutiny before people are allowed to modify. Otherwise, it will go into some set of data we can release to the public and ask public to modify it. Even if they make mistakes, if the 95% input is correct, you see the vast improvement of the data. So even 5% you can ignore if it is not going to harm the users anyway. But like roadmaps and other very crucial information, if you can't allow 5% errors. So we can't allow people to update. So that needs to be looked at very carefully. And then we have these organizations. We can easily share the authoritative versions of data among users and provide mechanisms for the creation of authentic data and metadata. So organizations of the data clearinghouses can share their own data, what we call as authoritative versions of data. This is the authorized version of data. And people can modify. They can improve it, but you cannot control the quality, but you don't guarantee that the product is having that kind of quality standard that you meant to maintain. So people can create their own authentic data and metadata, but there will be versions that we approve. So there are differences. There are versions. Now, if you produce something which has not been validated, and that will be your own data, but it is not the approved version of the data. So SDI solutions are used around the world to provide access to geospatial data and help nations solve problems collaboratively. So this industry is going to start contributing. Everybody joins the networks. Everybody provides data for the National Spatial Data Infrastructure. National Spatial Data Infrastructure is not a repository of data. We don't collect data and keep it in a large set of servers. We don't do that. The idea of SDI is to manage it. Now, if you look at the role of a government, in developed countries, the public transportation is only regulated by the government, provided by the number of private sector organizations, private sector people. So public transport can be provided by anybody on the competitive basis, but this maintain the regulatory body, the government maintain the standards. Without the standards, nobody can enter the market without having the proper levels of quality. So likewise, spatial data also, the government doesn't want to maintain it. Government doesn't want to manage it. Government doesn't want to collect data because spatial data is very voluminous. You cannot have very large servers at one place to keep all this data for the nation. So what we need is a collaborative effort. We need number of agencies network coming together and putting their data on the SDI so that others can see it. So it's a distributory type of approach, participatory approach. So like it's somewhat related to the cloud sourcing. Everybody in the society will contribute for that. And everybody will get the benefit of that. Everybody will use the resources available on that. So that's the kind of approach SDI will provide us. It's a distributed system. We don't go collect all the data and keep it our servers or government servers. Government is basically providing standards and the different regulatory mechanisms to manage the spatial data resources in the country. Government will not own all this data except for few sets of data which should be available to the public because these data have been collected using public funds. Therefore, the government is responsible for making this data available to the public without any cost. So those data can be made available through the various government agencies which are mandated to provide this information. But generally, the government will work as a regulatory body, introducing the standards, introducing the quality standards, including the data resolutions, data accuracy standards, data distributory standards, and data value addition standards. So all these things will come into play with the SDI or NSDI, and then people in the spatial data usage, those who use spatial data will find it extremely useful because they can find the data wherever it is available in the country. They can have access to this data with right permission. If you want to pay a fee, you can pay the fee and get access. If it is free, normally certain level of data are provided free of charge, but some of the data you need to pay and get. So some people have samples, like when you buy books, online books now, they will give you a few pages. The first few pages are given free of charge. You can go through it, you can peruse it, and then you can decide whether you want to read the entire book. Then, of course, you need to download, you need to pay for that. So likewise, what we have for the spatial data is we have the metadata available. So metadata will give them what is in the container. So what is metadata is the label on the cover, which says what is inside, what is the quality of the data, when it was created, who created it, for what purpose, and what level of accuracy it has, what kind of resolution of the initial data sources we used to develop this, and all that information will be on the label, which is called metadata. So once you are happy with the metadata, if you think, okay, this is the right kind of data that we want, we can ask for access permission. Some data access permissions are totally free, but some institutions may charge agreed fee to provide the access to the data. So you can't decide your own fee because there are certain regulatory mechanisms which we operate. So people need to follow those instructions. If you produce data, and the cost of the data or the data pricing should reflect the actual cost and a small amount of profit to maintain the systems. So that's very important. So what happens is we manage our spatial data collaboratively through a network where everybody has an equal and same level of permission to access the data. Depending on the input that you put, you can get rewarded by either selling the data or getting their whatever the other inputs coming into your data. Say, for example, you produce a certain set of data and you want to improve it. You have no resources to improve it. You give it to public free of charge and tell that, look, I have created this data. I need to check the quality of the data. So in your own area, you do the verification and we will pay you something for that and you will return the data back to us. So once we get the verification done at the field level, so you have a verified, accurate data set that you can publish. So it's kind of a mechanism for collaboration, mechanism for networking, mechanisms for identification or the discovery of the data, mechanisms for having data access at a reasonable price rather than spending for the entire the generation cost of the data. So that's very useful through the SDI. So we have been discussing the use of why you need to build an SDI. So in summary, this is what we discussed: build data once and use it many times for many applications. So we discussed this. You only need to generate once, but you can use it many times. You can update it and integrate distributed providers of data, which is called cooperative governance. You can combine, integrate, network a large number of data providers who are distributed all over. And then it may not be national institutions, because if you look at, we started one study. In fact, most of the data we got from USGS or US data sources. So the spatial data industry will not restrict into a national level, but it will be at the global level, but with the national level control and national level regulatory mechanisms will ensure that whoever enters, whether it is a local industry or international industry partners, whoever enters will follow the regulations. You cannot get into this and then do whatever you want. Everything will be regulated under this. And you can share cost of data creation and maintenance. Yes, very important thing, because some of the data generation, creation is very costly. So if you create the data for whatever so then you will be able to share the cost of data production with others. Others will be, because if you produce the data and keep it to yourself, you have to bear the total cost. And it will again cost to update the data. It will again cost to update the data. And what happens is, if you share the cost with others, if you allow others to use the same set of data, so that will help you to share the cost with other users. So it will be a very marginal cost for you. And also you will get funds to maintain update in the data, put new data in, and then maintain the data source continuously. And not only that, when you share the data, it will support the sustainable economic, social, and environmental development. Now, in a country, you need data for decision making. These days, even the president says they use data to make decisions. When it comes to the problem of rice availability in the country, they use data to produce. So if you use the right data, if you use the wrong data, if you don't have the quality data input, you will make wrong decisions, which will be disastrous. Therefore, in sustainable economic management or social management, social development, we need reliable data sets, and the spatial data are key to most of these sustainable management decisions. So whether it is economic, we need to have a good set of data for the nation, and that will, the NSDI will ensure that you will have access to these data. Even the government may pay for the data. So if it's a cost-effective the procurement. So if government find that the data available in the private institution is worth purchasing rather than developing their own data set. So you can see, but the compromise, if you increase the cost of the data, if the pricing of the data is very unreasonable, very high price, then people think, why should I buy this? I will produce the same data set and give it cheaper. So you cannot have unreasonable pricing in the data. So it has to be reasonable. It has to reflect the actual cost incurred to produce the data. And so once this data are available for the country, the decision makers will use this data for their decision making. The correct decision making will require correct data. So especially when it comes to environmental concerns, you cannot cover and monitor the entire environmental set of environmental parameters as government institutions. So it's useful to collect and compile data and integrate data so that you can have a national data set. So that will allow a high level decision making at the national level, because you have the data collected at the field level, collected at the very low spatial boundaries, and then integrate this data towards a national data set. So you can have the decisions based on this data. And also it is important that this industry develop. The industry will develop and it is very useful. So what happens is, unless you don't support the spatial data users, they will not create data, they will not use the data, they will not come up with useful products for the national development and also for their own development goals. So unless each other is data users support each other, we cannot have anything productive. So collaborations are very important for spatial data user community to prosper. Most of the countries, the introduction of NSDI helped the spatial data users to not only to get the data, but also to learn from others, have a formal and informal training opportunities through this initiative, so that people will know what other people have done, how other people have done, and the processes that are involved. And then as a user, you have the access to that information. You can develop from there. So whatever people have done, you can further improve it so that you can have a better product as output. That is how the science develop. So we produce something or we do a research, output is published so that the entire scientific community gets the awareness of what you have done. So people can use your product, people can use the results, or people can develop from there to further higher level. So that's how it works. So therefore, supporting spatial data user community, creating awareness, creating a good value chain for the industry, creating collaborations and information sharing, and then having a kind of a formal and informal training opportunities would be very useful for the betterment of the entire spatial data community. Okay, so spatial data infrastructure support ready access to geographic information. This is achieved through the coordinated actions of nations and organizations that promote awareness and implementation of complementary policies, common standards, and effective mechanisms for the development and availability of interoperable digital geographic data and technologies to support decision making at all scales for multiple purposes. Now, it's a long sentence, but it covers most of the important aspects. The spatial data infrastructure is achieved through the coordinated actions of nations and organizations. So we have countries coming together, organizations coming together to have coordinated, to have combined action, which promote awareness and implementation of complementary policies. Complementary policies. So in this, nobody is going to lose. Whatever you do in this NSDI, it is complementary. The policies that we introduce are complementary policies, which will help each other, which will support each other, which will benefit each other. Therefore, it is very important to look at and learn from others who have done it, get their experience and apply it. In fact, we have been promoting this spatial data infrastructure since 1999. In the government, we worked at different levels before 2015, during the era after the this civil war was over. We started working strongly to have a proper NSDI for spatial data in Sri Lanka. Even before that, we have a number of initiatives. The government got down some consultants from developed countries who have introduced this. And we had a number of workshops to discuss the issues. And I remember somewhere around 2007, I gave a keynote address at one of these workshops to discuss the issues at hand and how to resolve these, to have this kind of complementary policies in the NSDI. Common standards, everybody work on the same common standard. It's very important for whatever you do, complied with the available introduced standards. So you don't need to worry about the quality of the outputs. And also it says the availability of interoperable digital geographic data. Now, before people produce data, digital geographic data at various platforms, various levels, various formats, various following various protocols. But this data need to be able to work at various different platforms. Interoperability is a concept where once the data is put into the STI, these are interoperable data products. Whatever the service that we provide are interoperable. You can operate it across any network, any mechanism. So this can be data can be converted or used. Some of the data can be converted on the fly directly to other formats. Like if you look at the metadata that we do, even the metadata are in different formats. Once you enter the metadata in one format, you can convert without typing and putting the data again. You can convert it to various different formats. Same with the data. Once you produce the data according to the standard, it can be converted to any platform, any service requirement. So these are called able to use across any operating platforms. So interoperability is a keyword that we use in NSDI. So all these data are whatever we put as data products and services, they are interoperable. They work in any platform. Sometimes you may need some conversion, but they can be used. Some cases you don't need to have any conversion. It's you can use those things across any platform. So these actions encompass the policies, organizational remits, data, technologies, standards, delivery mechanisms, and financial human resources necessary to ensure that those working at the national and regional scale are not impeded in meeting their objectives. So once you follow these common standard complementary policies, effective mechanisms for the development and availability of interoperable data sets, it will ensure it will have a viable policies, it will be organizational, it will be assets to the organization, data, technology, standards, delivery mechanisms, all these are in place properly to ensure the people will not have any restrictions, any impediment in meeting their ultimate objectives in using the spatial data. So that's very important aspect. And I think with this, I will also tell you that from US, you have the experience in introducing history of spatial data infrastructure and European spatial data infrastructure. You have the Australian and New Zealand spatial data infrastructures, and you have initiatives for global spatial data infrastructure, which will combine all the regional infrastructure components together. So with that, I'll give you the first assignment. After like 5 minutes break, okay? Okay, there's a small confusion about the class that we have. Now, I told you last time, we have this spatial statistics, which is a basic course, which will be attended by the old group and the new group. Okay, so old group and the new group both will attend the spatial statistics course, which we had last week, right? And we have the spatial data infrastructure course only for the senior group, because we have not covered most of the other aspects to take this course. So today after the class, remote sensing class, the new group has also joined this lecture, assuming that this is spatial statistics. So we will have the spatial statistics course next Sunday, 10 o'clock, 10 to 12. And every other week we have until we make the further announcement. So this week, if you are interested, you can remain, but if you are a new group, if you are in new group, we will be offering this course again in the next semester for you after you complete some of the other courses. So if you want, you can leave, or if you want, you can still continue. But we will be offering this course again for the new group in the coming semester. So if I give you summary of what we have done through the chat, I'll send you the summary of what we have done so far. So I have sent you through chat what we have done so far. So that will be useful for you as a set of brief notes for what we have done. So you can keep a kind of copy of this transcript, which is a summary of the first hour of the lecture. Okay, so we'll continue. So I have to give you an assignment which you need to submit, you need to present in 2 weeks' time. And this is only for those who have completed most of the courses. So I think that those who have registration numbers with starting with 24 will not be able to complete this part. But if you have, if you are in the senior batch, not the batch which started 2 weeks back, if you are in the previous batch, which you have more or less you have completed 1 whole year, and then you have covered most of the courses and you are in a position to take this course as credit for this semester. Other people can listen an audit, but we'll be offering you this course again in the coming semester. So I will give you a few topics for you to choose. Can you send me a text message, chat message, those who are enrolled for this course as a senior student, previous year student? Can you send a chat message with your index number and the name so that I can get a list of those people who need to work on continuously in this course? Okay, Chintana Abesekara, you will have the topic for the presentation. What you will have is United States Spatial Data Infrastructure History. US History for Spatial Data Infrastructure. That's the topic for Chintana Abesekara. MRDD Karunaratna, you will have the history of European spatial data infrastructure. History, we are looking at only the history, how it has been evolved, how it has been developed, what are the key milestones in the development process. So, BI Tarangika, you will have the Australian and New Zealand spatial data infrastructure history, and Kuruvitage will have the global GSDI, Global Spatial Data Infrastructure Initiative, and Dhananjay, you will have African Spatial Data Infrastructure Initiative history, and Duminda Bandar Undugoda, you will have the Asian and Indian initiatives of NSDI as a history. So then we have Neranji Darshika Karunasena. You will use the Open Geospatial Consortium, OGC history, and Ratnayaka HRMDN, you will take the history of Southeast Asian NSDI initiatives, Southeast Asian NSDI initiatives history. And then we have Vaninayak. You will take the history of Inspire, which is a European version, Inspire history. And then Nishanka, you will take the Federal Geographic Data Committee of United States, how they contributed for the NSDI and the GSDI. So you will take that as a topic for the presentation. And Bandara, you will take the history of NSDI in Sri Lanka. Okay. So I have given you all, everybody, topic. Can you repeat? Can you tell your topic again so that we can have a record of other people also will be aware of what you have been given. Let me note down everything with the names. I didn't write down the names. So,
excuse me. Hello, sir.
Yes.
Sir, I am Vasantavi
Yes.
from. Sir. Sir, not mentioned, sir, my name.
Okay, we'll see. We'll go through this and then at the end. Chintana Abesekara 23211. What is your topic given to you?
Sir, SDI of US states. History.
USD, United States, NSDI history, right? It's not NSDI, it's a historical development, what you need to talk about.
Okay.
And number two, just give me a second. Okay, second is MRDD Karunaratna. Your number is 23305.
Hello, sir.
What is your topic?
History of European data infrastructure.
Okay, European. Right. Next is Tarangika.
Sir, Australian and New Zealand MSDI history.
Right. What is your index number? Registration number of PGIE?
23 215
23
215.
215. Right. Okay. Thank you. So that is Aus and New Zealand. Number 4 is Kuruvitagi. Right. Your number is 23055. What is
Yes,
your
sir.
topic we got?
Global GSDI
Yes.
initiative.
Okay. Global SDI Initiative History. Right. Number 5, it is Dhananjay. Okay. African SDI. Okay. I work as the consultant to some of the work of African SDI. So there are limited information available for Africa because they have not really having a fully functional SDI. So number 6, Duminda Bandara Undugoda.
Asian Indian NSDI initiative history.
Sorry?
Asian Indian NSDI initiative history.
Okay, take it as South Asian
South Asian.
and Indian. Right? South Asian and Indian. Right. And then we have Neranji Darshika Karunasena.
The history of OGC, sir.
Right. History of OGC. And next is HRMD in Ratnayaka.
Sir, Southeast Asian NSDI history.
Sorry?
Southeast Asian NSDI history.
Southeast Asian NSDI initiatives history. Right. And then we go to the next person. Two, 3, 2, 7, WAKTP, Vanni Nayak.
Yes, sir. My topic is history of Inspire history.
Okay, history of Inspire. INSPIR, right? Inspire, ENSPIR, Inspire. It's a European one, but it's a different, coming differently. So, next person is Nishanka, NPSG.
Sir, Federal Data Community Stand of USC.
Sorry?
Federal Data Community.
FGDC, Federal Geographic Data Committee, history. Okay. Then Shankar is done. Bandara.
Sir, my topic is history of NSDI in Sri Lanka.
Okay. Then we have Vasanta Vikramapala.
Sir, I couldn't get any topic, sir.
Okay, you can use your number is 23239, right?
Yes, sir.
Yeah, you can use Japan NSDI history, history of Japanese NSDI. Then we have Birasuriya.
Yes, sir. I didn't receive any topics.
Okay. The NWMDN. Okay, you can use the British United Kingdom UK NSDI history. Okay.
Okay, sir.
Right. Anybody else?
Sir, my name is not mentioned, sir.
What is your name?
PGD Pilapitiya 230464.
23064 PGD Pilapitiya. Okay, you can use Scandinavian history of NSDI, which includes Denmark, Norway, and Sweden. Right? Denmark, Norway, and Sweden. And then anybody else who missed? Okay, everybody got the topics, right? So I'll give you some instructions for you to prepare your presentation. First of all, just search through the internet and find information related to this. Right? And some people used to do this. Just put the keyword, what I gave you. Whatever you find, you just put it to a cut and paste and then try to present. It will not work. This is a first assignment. You will be evaluated based on your quality of your presentation. And I asked previously one of the groups to make a presentation on metadata. So what he did was, he put the keyword metadata in search. I asked him to find a project which benefited from the metadata. The presentation on a project which benefited from metadata towards the latter part of the course. So what he did was, he put the keyword metadata and search, and there was a project which says the project failed due to lack of proper reference to metadata. So metadata keyword was there because that project has not used the information available on metadata, and finally that project failed. So he selected this presentation, came and presented. Everybody, got a shock how he found the data. So don't make that kind of mistake. Find the information. We are only interested about the historical development up to now. Historical development up to now. And we need to focus historical development, how it has developed up to now. So what are the different initiatives? What are the major milestones they pass in the process? Say, for example, a new legislation or act related to the spatial data was enacted on this, likewise. And so if you look at some of the initiatives, like for example, the publication of SDI cookbook. It's a major milestone. And then some of the main milestones which achieved by this organization. So that need to include kind of a detailed description of the and your presentation should reflect certain aspects, how the technology evolved over the time in that particular initiative, how the policies evolved over the time, how the standards evolved over the time, how people got adapted over the time for this initiative, and what kind of new achievements, new development took place in the spatial data itself through this initiative. That's something which you need to look at. So you can look at the policies, operational policies, and the governance mechanism that were introduced through that. So you don't need to give what is SDI or what is NSDI definition, all that in your presentation, but you need to give a historical development aspects of NSDI in each of these topics that you get. So that's basically important. So look at the technology, policies, standards, people, and the data. How these things develop over the time. Anybody who has not received the topic? Anybody who has not received the topics? Okay, everybody got the topics right. So then we can continue the session. I'll share my presentation with you. And also, if you are not registered for this course at the PGIA, please register yourself for this course, and that will be improvement. Right. Okay. We'll get back to the lecture.
Sir, good morning, sir.
Yes.
Sir, I'm
Yes.
19202 WGKG Mathushara. Sir, I did not get a topic, sir.
Why did you wait so long?
Sir, I am my microphone is not working, sir. Therefore, I connect another one. I'm talking several
Okay, no
times.
problem. Okay, so what is your index number? 192020?
2022, sir.
202, right. And name WG. Okay, you have sent a message. Okay, you will use what is called Arctic SDI history. Right. Arctic SDI history.
Okay, sir. Thank you, sir.
Right. Okay. So idea of this making presentations is first you learn about the specific and then you share that information with others so that others also will be having some knowledge about one. So this is a kind of once you learn looking at the history, different stages of development, you will find it easy to understand when other people make presentations about their NSDI. So that's the idea. If I tell you, I have the presentations, but if I make the presentations, then you will be just listening. It will not go into your head. So if you prepare your presentation should have about 10 slides, 10 or 8 to 12 slides maximum, 8 minimum, 12 maximum. And you will have 10 minutes for the presentation, and we'll have a couple of minutes for discussion. So maximum your time will be 12 minutes for your presentation. 10 minutes is ideal. If you extend, we'll stop at 12 minutes. And we'll do it week after next. Week after next. That is today is 26, second, like 9. We'll have the presentations. Each one will give about 10 minutes, maximum 12 minutes. So we can cover everything on 1 hour, one session, 2 hours. Okay. And so you don't need to introduce what is NSDI and all that. So you start with your topic, give you information about the historical development, major milestones they passed, major achievements, and what is the level that they have in now up to that point. Right. Okay. So if you look at this diagram, which shows the conventional natural monopoly of national mapping agencies. What is our national mapping agency? It's a survey department. Okay. So this particular picture shows how the national mapping agencies manage their monopoly over the period, because they did not allow other people to come in. They have their products, whether it is useful for the people, they're not really interested. If you look at the example of survey department now, it's different, but earlier, as a national mapping agency, they had the monopoly. So conventional natural monopoly of national mapping agency, this is a common diagram. So you can get an idea. On the starting side, you have an archive of space and airborne images. You have satellite images and various airborne missions to collect the aerial photography, and they keep all these things in their archives. And then they have adapted the national positioning system, So that is for the geographic reference, the coordinate system that they use, either geographic or projection coordinate system. Here, national positioning system. So we have also evolved the positioning system to have now national with coordinate system. So then we have, from this data, they conduct ground surveys, and from ground surveys develop property registers and property maps related. These combined we call as cadastral information, cadastre. So they maintain cadastral inventory from this ground survey data of properties and produce property maps. Then this data with the positioning, they go into national topographic map compilation. If we look at the available topographic map versions of Sri Lanka, before 1982, they produced what is called the 1-inch maps for Sri Lanka, the topographic maps, but later on converted to the 50,000 scale. So we have a topographic map compilation as a key agenda for the National Mapping Agency, from the spaceborne and airborne data. Then, so we have the official geographic names included in these topographic maps, and then we go for cartographic product, and then we produce official national topographic maps for the country. So these maps, whatever we want maps, we have to satisfy with this product according to the National Mapping Agency. They produce official national topographic map, and everybody is supposed to use that. There's no other choice. Many different clients to be satisfied with one standardized product. Over the years, national mapping agencies keep their monopoly. They allow people to produce validated maps. They produce their own maps, topographic map compilation, and then people have to use those maps or find some other alternative. So you can see it's very, very unfair system to have a national monopoly for national mapping agency, because nobody else can enter into this. Nobody can demand the kind of data products that they need to be given. But things have changed over the time. And if you look at the modern natural monopoly of national mapping agencies, it's the mandate has been changed. So you have the what is called the foundation data, the basic data layers, we call as foundation data. We'll come into that topic later in the course. Foundation data, rather than having a natural monopoly, now we have input from many data sources for value-added production. So foundation data, we have now, earlier it was only the National Mapping Agency produced, but now a lot of stakeholders provide inputs from various data sources and produce value-added products. So if you look at the green arrow, from other external data to analog value-added production, green arrow, that says a lot of other users other than the NMRA. If you look at this side, look at this side of the presentation. So this green arrow indicates a large number of agencies input data into the this product. So that's the key thing that we want to highlight. And so you can see the green arrow here also, all the other external data to have value-added digital production for GIS market. So that's the kind of, so if you look at the inside, satellite and airborne imagery archives, so national positioning is same as previously. Ground surveys, you have property registry, property boundaries, and then you have national, instead of a topographic data compilation, now we have national elevation model, or the elevation data as a digital elevation model, national topographic template with a geospatial reference where you get national geographical names database here, and then you combine it ground surveys and produce this. So finally, an entire thing will produce value-added digital production with this lot of input coming from outside data agencies. So that way, the input to the National Mapping Agency, although it may still maintain the monopolistic approach, but a lot of outsiders can contribute the data for this mapping service. So earlier we had analog products, paper maps that we produce, which becomes obsolete quickly, some of the information that put in, but now we have either analog data or map products, or you can have the digital data now, which is available in the GIS market. So, basic difference between the historical, the traditional monopoly of National Mapping Agency and the contemporary role of National Mapping Agency, that now we will have the digital data products available in the market, not like before. And we also can demand various data products derived from this. So that's also possible. You can take the data as data layers from the digital data production. So you can have various thematic data layers which have been contributed for the development of this the basic foundation data set through the National Mapping Agency. So that's a very key, remarkable achievement. Our survey department, some of you are working for survey department, is fairly reluctant to adapt these new changes. So it's very slow progress in adapting the new developments in the spatial data and spatial data industry, but however, now they have somewhat opened up and then gone into the basic developments required for this. Now, coming back to the topic of national data sharing mechanisms, which is a core of spatial data infrastructure, because it is the resource that you share, that is the resource that you use commonly, so that this initiative becomes successful. It is the data. It is the data, it is the data products, and it is the information products that we are looking at. So this is some of the mechanisms. So first of all, it is important to have awareness of characteristics of digital spatial data. Like now we go for digital approaches, so we need to look at the characteristics of digital spatial data, because NSDI requires everything to be in the digital form. We don't work with the analog products, which creates a lot of issues. So we need to learn what are the basic characteristics of digital spatial data. Can anybody tell some of the characteristics of digital spatial data? Going back to the coordinate system. Going back to the coordinate system. Earlier, if you look at maps that were produced by the survey department, say take a 50,000 map, a metric map that is produced. Earlier, before 1984, maps that were produced from the survey department had the geographic coordinates, lat long, along the map boundary. And the newer maps after 1984 included both national grid as well as the geographic code, latitude, longitudes on the maps. Right? So whichever the maps, whether it is lat long or whether it is national grid plus lat long, these maps that were produced, paper maps, will not give you opportunity to change the coordinate space. You cannot convert this into a different coordinate system. Say, for example, you want to go for a UTM coordinates. You cannot do it. But with the digital spatial data, it's a matter of seconds you can convert the entire data set into whatever the coordinate system that you define. So if you define a datum and the coordinate space, what is the datum that we use for Sri Lanka now? Anybody? What is the datum that we use for coordinate space, or to have the datum for the data sets? Anybody?
SLD 99.
Okay, so where is the location? What is the location specific for that? Now, if you look at the data set WGS 84, World Genetic Survey 1984, it's a global datum, right? It's a global datum. Now, for Sri Lanka, what is the datum we use? India? Yeah. In India, they use the datum Everest. So everything is reference based on the reference ellipsoid, related to the Everest. Here in Sri Lanka, we use Kandavala. Right? Where is it located? Anybody? The survey should know. Huh? No. That is not the data we use. The Pitrutalagal is something else. Kandavala datum. Where is Kandavala?
Gampaha district.
Yes, Gampa district. Where about Gampa district? Little north of Katnaik Airport. North of Katnaik Airport. Right? So, somewhere called, from where I'm exactly not sure about the coordinate of that place. I have the coordinate, but it's somewhere around Katana. So north of Katunayaka. Now, what is Pitrutalagala then? What is Pitrutalagala?
5 lakhs XY coordinate point.
That's the true origin of the coordinate space. So our coordinate space is defined based on the Pitrutalagala. So basically our coordinate space is XY, two-dimensional space at Pitrutalagala. You get anything northeast from Pitrutalagala will receive positive data. Anything southwest of Pitrutalagala will receive both X and Y negative data. Right? If you look at the map of Sri Lanka, if you put the starting point at Pitrutalagala, you will have coordinates plus X and Y coordinates, plus minus X and Y coordinates, minus plus XY coordinates, and minus XY coordinates. To avoid this problem, to avoid this requirement of the sign, they moved from Pitrutalagala, the starting point. They gave a origin. Pitrutalagala was shifted to 200,000 meters south and 200,000 meters west. Right? So when you have that, the entire Sri Lanka is covered with plus coordinate space. That's the idea of bringing it down to a false origin. From the true origin is shifted to 200,000 or 200 kilometers south and west. So that's the idea. Anyway, coming back to this digital spatial data, one of the characteristics, you can immediately convert the coordinate space to a required one without much difficulty. And also, use digital data rescalable. You can produce at different scales. You can produce the data at different scales. Rescalable data. You can do it on different scales. So when you do an overlay operation, you need to have all the layers in the same resolution so that you have a smooth overlay operation. to have a smooth overlay operation. So to do that, you need to have the scalable digital data layers, scalable digital layers. So in that sense also, it's the characteristics of digital spatial data. It's a scalable. You can scale the resolution of the data. You may not add any new information by improving the resolution, but yet you can rescale the data, whatever the data containment, you can rescale. Paper maps, analog maps, you cannot do that. You have given a scale and you have to live with that scale. And digital spatial data can have updates, because you can, if you find some information is not correct, you can update it. But map data, paper maps, you cannot update unless you issue a new version of maps, revised version of maps. So it takes long time because every time you find a mistake, you cannot go and change it. But digital data, you can change it. So there are so many characteristics of digital spatial data. And the paper maps, you cannot perform any operation on the paper map. But digital data, you can do all kind of operations with the data. So there are lots of critical characteristics of digital spatial data that makes them superior to the original existing paper maps. Therefore, the country as a whole will benefit by having digital spatial data libraries rather than compile map series in their archives. It's very useful. So at least now embarked on producing paper maps, because some people will still come and ask for paper maps. Right? For reference purposes, they can use the paper maps. But they are now modified. Their products have been diversified to include the digital products. So when you purchase digital products, the other advantages, a characteristic of digital spatial data is you can disintegrate this data. You can disintegrate this data. What do you mean by disintegrate this data? You can have the topographic map, you have land use, topography, towns, villages, townships marked, hospitals marked, schools marked. You don't need to have all that land use layers separated from the data. You can have elevation, contours separated from the data. You can have a different buildings layer. The drainage structures, you can have a separate drainage layer. So it's easy to disintegrate the data that you have. So this is very important to be aware of the characteristics of digital spatial data which make them superior to the all form of mapping products that you have on paper. Okay, so there are 11 points. I discussed only one. And if you can find other characteristics of digital spatial data, we can bring into discussion. I'll stop here for the day, and we will have the continuation after 2 weeks after the presentations. Any questions that you want to ask? If not, we'll wind up the session, and we will meet next week, 10 o'clock for spatial statistics class.
Recording stopped.